Video of module Introduction to Networking. My name is Sanjeev. Currently, I'm working as a software engineer in Microsoft and as an educator at Level. In this video, we are going to discuss about different kind of data transmission modes. We will see how we can categorize different data transmission modes based upon the different categorizations. Then we will see their advantages and disadvantages. At the end, we will conclude with what all the aspects you should keep in the mind whenever you are choosing a data transmission mode for your case. So let's just move forward with what actually data transmission modes are. So here your transmission mode refers to the mechanism of transferring data between two devices connected over a network, right? So data transmission mode actually defines the direction of the flow of information between two communication devices. That's why it is also called as data communication or the directional mode. It specifies the direction of flow of information from one place to the another in a network, right? I hope this is clear to you that what actually data transmission mode is. It is something which would define the direction of flow of information between two communication device, right? Now, in the further videos, when we would be talking about OSI layer model, in that we will see how physical layer would be dedicated to data transmission in the network, and it would mainly be deciding the direction of data in which data needs to travel to reach the receiver node or system, right? So don't worry about it. We will be discussing that in OSI layer model. So right now, you already know that what actually data transmission mode is. As we have discussed, it would be defining the direction of flow of information between two communication devices, right? Now, let's discuss that how you can categorize your data transmission modes based upon different characteristics. Let's just see. So basically we categorize your transmission modes based upon these three categories. First is based on your direction of exchange of information. Based upon direction of exchange of information. Right? This is one of the criterias based upon which we categorize the modes. Another criteria is that we would be categorizing your data transmission modes upon the synchronization between transmitter and receiver. So second is based on synchronization between transmitter, or you can say sender, and receiver, right? Now here comes the third category. So based upon the number of bits that we are sending simultaneously, based upon this we would be categorizing your data transmission modes. So third is based on number of bits sent simultaneously. Right? So these are the main three aspects based upon which we will categorize your data transmission modes. Now let's see what are the types of data transmission modes that we are categorizing on these bases. So first is on the basis of direction of information, or you can say direction of exchange of information. Exchange of information. So on this basis, we can categorize your data transmission modes into three types. These three types are, first is your simplex data transmission mode. Second is your half duplex transmission mode, half duplex transmission mode, right? And third is your full duplex transmission mode. Okay. So based upon the direction of exchange of information, here we have three types of data transmission mode: simplex, half duplex and full duplex, right? Now let's come to the second category, how we categorize your transmission modes based upon synchronization. So here second is, let me just scroll a page a bit. So based on synchronization, between transmitter and receiver, between your transmitter or you can say sender and receiver. So here based upon this, we can categorize your transmission modes into two types. First is synchronous and second one is asynchronous. Okay. So here we have categorized your data transmission modes based upon the characteristic of synchronization between your transmitter and receiver. So two types are synchronous data transmission mode and asynchronous data transmission mode. Now the last is based upon the number of bits that we would be sending simultaneously in the network. So third is based on number of bits sent simultaneously in network. Right? So based upon the number of bits, we will divide your transmission modes into two types. One would be your serial mode and another would be your parallel mode. Okay. So these are the categorizations of your data transmission modes based upon different categories, right? Now, next thing that we are going to do is we would be discussing all of these modes in detail, what these mode actually means, what are their advantages, disadvantages and use cases, right? So basically we are dividing your transmission modes into three types based upon their direction of exchange of information. So simplex, half duplex and full duplex. So firstly we are considering simplex one. Let's see what actually simplex mode is. In your slide, as you are able to see, in this type of transmission mode, data can only be sent in one direction. That is, your communication would be unidirectional, right? In this mode, a sender can only send a data but can't receive it. Okay, so we can't send a message back to the sender. That's why unidirectional mode communication is done in simplex system, where we just need to send a command or signal and we don't expect any kind of response back, right? So example of it can be your loudspeakers, your TV, radio, keyboard, monitor, mouse, etc., right? Where you are just sending an information but you are not receiving anything back. Okay. So here, if we will describe it through a diagram, so let's just draw. So here in simplex, if you are having a sender, which is some device, if you have a sender, right, and you have another device which is your receiver. So here sender can only send the information or you can say data to the receiver, but Receiver can't send any signal back. So this is your device 1, that is sender, and this is your device 2, which is receiver, right? It is like radio. On radio, some information comes from the sender to the radio, but radio can't send any information back. Similar like your TV. On your TV, for example, on the cable TV, when you turns on TV, some information is coming to the TV, you are watching that, but you can't send any signals back, right? This kind of data transmission mode is called as simplex, in which data can be traveled in only one direction from sender to receiver. Okay. So now you know the use cases of this particular transmission mode, simplex mode, that it is only one-way communication, that sender can only send the information to the receiver. So actually it is mainly used in business fields, as in sales, which doesn't requires a corresponding reply. Okay. It is similar to a one-way street. For example, radio, television transmission, keyboard, mouse, etc. Right? Now, what are the advantages of a simplex transmission mode? Actually, it would be able to utilize the whole capacity of your communication channel during the data transmission, because this is the only data traveling in one direction. There is no other data. So it would be able to use the full capacity of your communication channel, as well as there would be least or not data traffic, right? There won't be any data traffic, or the minimum data traffic that would be there, because your data is flowing only in the one direction. So there won't be any traffic, okay? Or the least minimum traffic, right? Now, what are the disadvantages of this simplex transmission mode? Disadvantages are it is unidirectional in nature, so no intercommunication is there between the devices. There is no mechanism for information to be transmitted back to the sender. So there is no mechanism of acknowledgement. For example, if you have sent some information through simplex mode to the other device, you can't acknowledge or confirm if other device have got that information or not, right? Because that device can't send any information to the first device back. So this is only one-way communication. That is its disadvantage. Now, let's move to your next mode. So, according to a direction of exchange information, first mode was simplex, second is half duplex. Now, let's see what actually this half duplex mode is. So, it is the data transmission mode in which data can flow in both the direction, but in one direction at a time. So, that's why it is also referred as a semi-duplex. Here, you can say that each station can transmit or receive the data, but at the same time. When one device is sending some information, other can only receive, and vice versa. So have you ever saw someone talking upon a walkie-talkie? You must have seen that when A is having a walkie-talkie and sending some information, so what A do? A would say, okay, this is the information from A over. Why on walkie-talkie people use that over? So they basically send the signal that my information that I want to convey is completed and it is over now. So that when person B would be getting that information on his or her walkie-talkie, so they would be able to know person A has conveyed their thing. Now you have got everything if you are able to hear over at the end, and then you can convey your information to the person A again, right? So this is how here both the walkie-talkies can connect to each other, can convey their information to each other, but at a time you can convey or you can send the data from one walkie-talkie to the another, and another would only listen at that time, right? So same kind of example you can read in your slide too. For example, on a local area network using a technology that has a half duplex transmission, one workstation can send data on the line and then immediately receive data on the line from the same direction in which data was just transmitted. Hence, half duplex transmission implies a bidirectional line. one that can carry data in both the direction, but data can be sent in only one direction at a time. So same example of walkie-talkie is there, in which message is sent one at a time, but message can be sent in both the directions, right? Both the person can send their message. A can send the message to B, B can send the message to A. But only condition here is that only one message would be conveyed at a time, right? In this type of transmission mode, the entire capacity of the channel can be utilized for each direction, and transmission line can carry data in both directions, but the data can be sent only in one direction at a time. This type of data transmission mode is used in the cases where there is no need for communication in both directions at the same time. It can be used for error detection when the sender does not send or receiver does not receive the data properly. In such cases, the data needs to be transmitted again by the receiver. Okay. So here, apart from walkie-talkie, you're one of the most common example of half duplex is internet browser also. There also, we are sending the information one at a time. When we are sending information to the browser, browser is not sending any information to us. And when browser is sending information to us, we are not sending any information back to browser then, right? So there also we are following the half duplex mode. Now we have seen the use cases of half duplex mode. Let's see what are the advantages and disadvantages of half duplex transmission mode. So it basically facilitates the optimum use of communication channel, as there is communication in one direction at a time, and it provides you the two-way communication as well. So these are its advantages. Now if we will talk about the disadvantages. So the two-way communication can't be established simultaneously at the same time. It can be a disadvantage, right? And there can be a delay in transmission, as only one way communication is possible at a time. So if someone have to send their message instantly on this half duplex mode, that might be delayed just because maybe right now your device is in receiving mode by your half duplex, right? And after that only you would be able to send some information. So there can be that communication delay. Cool. I hope this is clear to you that what actually half duplex mode is and how communication take place in half duplex data transmission mode, right? So here we have just studied about this half duplex mode. Now next is full duplex. So let's just see what happens in the case of full duplex. So here in the case of full duplex mode, we send the data in both the direction, and it is also called as the bidirectional in other words, right? So data can be sent in both directions simultaneously. So here full duplex is the transmission mode in which data can flow in both direction at the same time. So it is bidirectional by nature. It is the two-way communication in which both the stations can transmit and receive the data simultaneously, just like on your phone. At a particular time, one person can speak as well as listen, right? So full duplex mode has the double bandwidth as compared to the half duplex. So here if we will draw a diagram of it, in case of half duplex, what was happening? If there was a sender and if here was a receiver, so sender can send a data to receiver and receive. When this receiver would be acting as a sender, at that particular time the sender would be acting as a receiver, right? So the information was being transmitted one by one, right? At a particular time your data was flowing in only one direction. Now if we will talk about this full duplex mode, in full duplex transmission mode, at a particular time, your data can flow in both the directions, from sender to receiver as well as from the receiver to the sender. So here, if this is let's say your sender and this is let's say your receiver, Sender is sending the information to receiver, but at the same time, when sender is sending to receiver, receiver can also act as a sender and send some information to receiver, where your sender would be acting as a receiver. So it's just like your mobile phone, where person A can talk as well as can listen to B. Similarly, B can talk as well as listen to A, right? So there two-way communication is happening. That is what we call as full duplex mode. So here this full duplex mode is having the double bandwidth as compared to the half duplex mode. The capacity of the channel would be divided into two direction of communication. This mode is used when we need the bidirectional communication, right? For example, on a telephone network. So now you are already aware about the use case of full duplex mode. Let's see what are the advantages as well as disadvantages of this full duplex mode. So here the two-way communication can be carried out simultaneously in both the direction. This is an advantage, and it is the fastest mode of communication between two devices, right? Because at a particular time you are sending as well as receiving the data, so it's very fast. If we will come to disadvantages of this full duplex data transmission mode, the capacity of the communication channel is divided into two parts. Also, there is no dedicated path for data transfer, right? As well as here the improper channel bandwidth utilization, as there exist two separate paths for two communicating devices. Okay, so these are the disadvantages, that capacity of the communication channel would be divided and bandwidth of your channel would be improper, just because now it is having two separate paths. Okay, so I hope this is clear to you that what are the use cases, advantages and disadvantages of your full duplex mode here, right? Now let's just see the other different modes of data transmission that we have discussed about. So the other modes that we have discussed about was, based upon your synchronization, we were having synchronous and asynchronous data transmission mode. Okay, let's firstly check what is synchronous data transmission mode. So the synchronous transmission mode is the mode of communication in which the bits are sent one after the another without any start or stop bits or gaps between them. Okay, so actually both the sender and receiver are placed at the same system clock, in which synchronization is achieved. And then in a synchronous mode of data transmission, bytes are transmitted as block of continuous stream of bits. Since there are no start or stop bits in the message block, it is the responsibility of the receiver to group all the bits correctly, and the receiver counts the bits as they arrive and group them in the 8 bits unit, which is basically your byte. So the receiver continuously would be receiving the information at the same rate from the transmitter, and it would also listen to the message even if no bits are being transmitted. Okay, so your receiver would keep listening if the transmitter is sending any message, right? And as soon as transmitter would be sending the message, receiver would receive that. Otherwise, it would still keep the listener on, that in case if transmitter would try to send some message. So here, if we will draw a diagram for the same, so here for your synchronization or synchronous data transmission mode. So here for synchronous, we can say if you are having a sender here, let's say this is your sender, and let's say if this is your receiver. So you would be sending the information in your bytes here. So for example, here you are having a byte as 1100 1100. Okay. Then here, let's say you are having the another byte of information, let's say 10101100, something like that. It can be anything. And in this particular direction, your data is being flowed, right? So this is basically your synchronous mode, right? And here, as you have seen, we are sending the information in this particular way. So as I have just drawn this particular partition, so in actual, how this partition would be happening between the bits. So generally we send a character in between and we call it as character level synchronization. So we would be sending a character after every byte in the synchronous way, so that it would be differentiated that now one byte is completed and then next byte is started. For example, it would be sent as 11001100, comma 10101100. So this comma would be acting as a separator, okay, and we will call it as character level synchronization, right? So I hope this is clear to you that how we are sending the data in synchronous mode from sender to receiver. So receiver would always keep listening to the sender even if sender is not sending any data, so that as soon as sender would send some data, receiver would receive it. Okay. Receiver would group all the bits on its end, right? Now, what are the example of this kind of communication? So generally we use this synchronous mode in your CPU, RAM, etc. Right? Now, what are the advantages of these kind of mode? So actually the transmission speed is very fast as there is no gap between the data bits. Data bits are getting sent synchronously without any gap, right? So that's why it's very fast. But another thing is that it's very expensive. As you can see, there is only one communication channel, right, on which we are sending the data synchronously, one bit after the other, right? So that's why it's little expensive than the other modes. And it is one of the reasons you would see your RAM is also expensive, right? Because it is following the synchronous transmission mode, which is eventually expensive. Okay. Now, let's come to your another data transmission mode based upon the synchronization between transmitter and receiver. And this another mode is asynchronous mode. So what happens in case of your asynchronous mode? Let's just see. Let me just scroll the screen a bit. So the asynchronous mode is just a mode of communication in which start and stop bit is introduced in the message during transmission. The start and stop bit would ensure the data is transmitted correctly from the sender to the receiver. And generally, start bit is 0 and end bit is 1. Asynchronous here means asynchronous at the byte level, but still here the bits are still synchronized. The time duration between each character is same and synchronized, okay? So only the bytes are asynchronized. Bits are synchronous here inside a byte. In an asynchronous mode of communication, data bits can be sent at any point of time. The messages are sent at irregular intervals and only one byte can be sent at a time. So this type of transmission is best suited for the short distance data transfer. Okay. So here if we will draw an example of it, asynchronous, right? So here if you are having a sender and a receiver, so here you will be sending the information as, let's say there would be 2 bytes, and for these 2 bytes their starting character would be 0 and ending character would be 1. It is just signifying that from here your byte is started from 0 and it is being ended at 1. All the other characters, or you can say all the other 8 bits, would still be synchronized. So for example, let's say we are sending here the data, this, and let's say here we are sending the data 10101100, right? So all the other bits are still synchronous, but it's just that the byte is starting from 0, ending at 1, and it's possible that there can be gap between the bytes. Okay. So this is your asynchronous mode where your every byte would be having a stop bit. So here this is the stop bit and 0 is start bit. Okay. Another thing is that bytes are sending asynchronously. Bits inside a byte are synchronous, but bytes are sending asynchronously and there can be the gap between the bytes. Cool. So where this kind of transmission mode can be useful. So it can be useful in your data input. from your keyboard, mouse for the computer. So for example, if you would be clicking on the keyboard, so that won't be synchronous. It's your wish when you want to click on the keyboard, right? And when you want to give the input. So your system won't keep listening to the keyboard that, okay, keyboard wants to give me input, let's keep listening to it. It won't do that. As soon as you would press a key on the keyboard, then an interrupt would be raised, and then your system would be listen, okay, now a key is pressed, let's see what this key is saying, right? Otherwise, it won't keep listening to only to your keyboard, right? So this is what your asynchronous mode is. What are the advantages of this asynchronous transmission mode? So it is cheap and cost effective, just because here you don't have to send the data in the regular manner and you can take a gap in between, right? As well as your receiver won't be listening to the sender all the time. So that's why it's cheap and effective. Another thing is here data transmission accuracy is high, just because here we have start and stop bits. So we know when your byte is starting and when your byte is stopping, right? So that's why here data transmission accuracy is very high. Another thing is that what are the disadvantages then of this kind of asynchronous transmission mode? So here data transmission can be lower due to the gaps that are present between the different blocks of the data. Okay, so that particular gap can introduce the slow time factor in the data transmission, right? I hope this is clear to you that what is asynchronous and synchronous mode of data transmissions, right? Now let's see the next one, which is based upon your number of bits which are sent simultaneously in a network. So based upon number of bits that are sent, we have two modes. One is serial and another one is parallel. Now let's see what these two modes are saying. Firstly, let's go with the serial mode. Let me just scroll. Okay. So here, let's say serial. In serial data transmission mode, actually it is a mode in which the data bits are sent serially one after the other at a time over the transmission channel, right? So for example, here, if you have a sender and here, if you have a receiver, so the data would be sent as, for example, B8, B7, B6, B5, B4, B3, B2, B1. Just give me a second. Let me just make it more clear here. That these are the bits which are being sent at a particular time from your sender to the receiver in this particular direction, right? So all the bits are sent through one communication channel, or you can say through one transmission channel from your sender to receiver, right? So here we can see these bits are being sent serially. It needs a single transmission line for the communication. The data bits are received in synchronization with one another. So there is a challenge of synchronizing the transmitter and receiver. Okay, as the data is sent in the synchronized manner, so in the same way data should be received in the synchronized manner as it is being sent. That's why firstly it is necessary that your sender as well as transmitter should be synchronized with each other. Now in the serial data transmission, the system takes several clock cycles to transmit the data stream. In this mode, the data integrity is maintained as it transmits the data bits in specific order one after the other. This type of transmission mode is best suited for the long distance data transfer, or the amount of data being sent is relatively small. So where you can see this serial data transmission mode, if you remember on your computer there is this serial transmission port, right? Serial ports which we usually call. So when you transfer some data between two computers using their serial ports, so there your data is being transferred using the serial transmission mode, right? Now let's see what are the advantages of this serial transmission mode. So it can be very useful for long distance data transmission as it is very reliable. Here we are sending all the bits one after the other in the synchronized manner. So that's why it's very reliable. Now the next thing is that number of the wires and complexity is very less here, as we are using only a single communication channel to send our data, and it is cost effective also, as we have to maintain only one single channel, right? Now, what are the disadvantages of the serial transmission mode? So the disadvantages, as we are using only a single transmission channel here, so the data transmission rate is very low, just because we are sending the data only through a single transmission channel, right? So I hope you are able to get all the advantages, disadvantages and use cases of the serial data transmission mode, and you are able to understand what actually serial data transmission mode is, right? Now, the another part of it, or another type of the data transmission mode based upon the number of bits sent simultaneously, we have the parallel data transmission mode. Let's just see what this parallel data transmission mode is. So if we will talk about this parallel data transmission mode, it is the transmission mode in which the data bits are sent parallelly at a time. In other words, you can say there is a transmission of n bits at the same time simultaneously. So for example, if you are having the sender and let's say this is your receiver, so the data bits that you would be sending like B1, B2, B3, B4, B5, B6, B7 and B8. Okay, so you would be sending these bits at the same time, right, in this particular manner. Sorry. So your bits are going to be sent all simultaneously. These are not being sent one after the another, but all of them we are sending simultaneously. Okay. So this is a parallel mode of data transmission, right? Here, multiple transmission lines would be used. So multiple data bytes can be transmitted at a single system clock. Okay. This mode of transmission is used when a large amount of data is to be sent in a shorter duration of time, as we can send a larger amount of data here, right? It is mostly used for shorter distance communication. For n bits, where we need n transmission line, so the complexity of this particular network increases, but the transmission speed is also high, right? If two or more transmission lines are too close to each other, then there is a disadvantage of interference of data. If two transmission lines are very close, then there can be the chance of interference of data and disregarding the signal quality. So the example of this kind of data transmission is between the computers and printer. We can send the data like this in multiple bits from a computer to a printer, right? What are the advantage of this parallel transmission mode? So it is easy to implement programmatically, right? And here the data transmission speed is very high as there are n transmission channels, right? Now what are the disadvantages? So disadvantage is that it would require more channel, so it's not so cost effective, right? It's very cost ineffective, and interference can be there in data bits, likewise in video conferencing also. So that can be the main disadvantage of parallel transmission mode, right? So I hope all these data transmission modes and their differences are clear to you, right? Based upon the different categorization. Now to conclude this, after learning about all the various transmission modes, we can conclude that some points needs to be considered when we are selecting a data transmission mode. What all those points should be? So one is transmission rate. You should know that according to your case, which transmission rate would suit you, right? The next is the distance that your network is going to cover, based upon which you can select your data transmission mode. Another main point is the cost and ease of installation. Obviously, that's important. You should consider the cost and ease of installation. And the next and most prominent thing is the resistance of environmental condition that you should take into the consideration, that according to environmental consideration, which particular data transmission mode would suits you the best, right? So I hope this is clear to you and you are able to learn something new from this particular video and you are able to understand everything that we have discussed here. So let's meet in the next video. Till then, bye bye, take care, thank you.